Let's now consider sample problem number 6. A hollow beam is shown in the figure. So, meron tayo dito hollow beam. So, dito sa gitna natin. So, wala tayong konkreto dyan. Assume F prime C that is equal to 28 megapascal. Fy is 345 megapascal. It is reinforced with 4 pieces, 25 mm diameter bars. We are tasked to find the design strength of our beam. So, for this one, kailangan nating malaman kung irregular ba yung section natin or hindi. So, sir, paano po natin malalaman yon? So, compute muna natin yung value ng ano natin dito. AS muna. So, your AS is, meron tayong 4 na piraso ng bakal na merong 25 mm yung diameter. So, you have a value of your AS which is equal to 625 pi. So, for your first step, since meron tayong singly reinforced beam, so mangyayari dito is we're going to assume, we'll begin with an assumption. So assume your tension still will yield. And we're going to assume also that A is equals to eto na thickness na to, which is equal to 150. So, equate na. So, i-assume natin na A is equals to 150 para malaman natin or matansya natin kung lalagpas ba dito yung compressive force natin. So, kapag in-assume natin na tension still will yield, the value of your Fs is equal to the value of your Fy. So, unahin mo muna natin kunin yung ano natin, tension natin. So, that is equal to As multiplied by Fy. So, the value of your Fy, that is 345 megapascal. So, you will have a value of tension which is equal to 677.406 kilonewton. So, etong tensile force na to, yung ibabalance natin dun sa compressive force natin. Kasi C is equals to T by engineering mechanics. So, hanapin natin yung C sub F natin. So, you will have 0.85, yung stress sa concrete natin, multiplied by yung thickness natin, which is yung A natin, multiplied by yung width natin dito. So, that is equal to C sub F. So, you have 0.85 F prime C. Meron tayong 28. Multiplied by yung T natin na 150. Multiplied by yung total width natin. So, 125 plus 250 plus 125. So, you will have a value of 500. So, yung value ng C sub F natin, that is equal to 1,785 kilonewton. So, for this, meron tayong value ng T, meron tayong value ng C sub F natin. So, yung C sub F natin, sobrang laki ng value niya. If we were going to compare that to the tensile force. So, yung value niya is 1,700. Yung tension natin hanggang 6,000, hanggang 600 lang. So, with that, since mas malaki yung CF natin compared to the value of your tensile force, so, mangyayari niyan is yung A natin, that is less than to the thickness natin na 150 mm. So, therefore, we can now say na wide rectangular beam lang yung gagamitin natin dito. Kasi ang gagawin natin para mapag-balance natin yung T at saka yung CF, babawasan natin ng area yung C sub F natin. So, ang babawasan natin yan ng area, mababawas yung value ng A natin. So, next, C is equals to T tayo. So, for this one, we're going to assume that our tension still will yield. So, if that will yield the value of your Fs, that is equal to the value of your Fy. So, C, that is 0.85. Yung F prime C natin, that is 28 multiplied by yung A na hinahanap natin, multiplied by yung buong width natin, which is equal to 500. Equals yung AS natin, which is equal to 625 pi, multiplied by yung Fy natin, which is equal to 345. So, the value of your A by shift solve is equal to 56.925 mm. So, which is less than sa thickness natin. So, okay siya. So, let's now compute for the value of your C. That is yung A natin divided by the beta. Since yung NSCP 2015 yung gagamitin natin, limiting factor that is 28, sakto lang. So, yung beta natin that is 0.85. So, the value of your C is now equal to 66.97 mm. So, after that, we're going to check if assumption is correct. So, paano natin gagawin yon? We're going to calculate for the value of your Fs. That is equal to 600D. So, yung D natin, that is 725 minus yung C natin na 67.97 over 66.97. So, you will have a value of your Fs which is equal to 5,895.446 megapascal. Since it is greater than to the value of your Fy, which is only equal to 345 megapascal, therefore, assumption correct. So, happy tayo niyan kasi your tension still will yield. So, with that, since nag-yield na yung bakal natin, let us now calculate for the value of your ultimate moment capacity, which is denoted by reduction factor multiplied by the nominal moment. So, what will be the value of your reduction factor? Since the value of your Fs, which is equal to 5,000 plus, which is greater than to the 1,000 megapascal na limiting value natin, therefore, the value of your reduction factor is now equal to 0.90. So, hanapin na lang natin yung value ng nominal moment natin, which is denoted by C multiplied by the moment arm of D multiplied by minus A over 2. So, yung C natin, that is equal to 0.85. Yung F prime C natin na 28 megapascal. Yung A natin, which is equal to 56. So, that is 56.925 multiplied by yung width natin na 500 multiplied by yung moment arm natin na D. So, we have 725 minus A over 2. So, you have a value of your nominal moment capacity which is equal to 471.814 kilonewton meter. And computing for your ultimate moment capacity reduction factor na 0.90 multiplied by the nominal moment na 471.840. So, you will have a value of your MU which is equal to 424.656 kilonewton meter. So, this will be the value of your ultimate moment capacity.